Okay, so for evaluating functions, what we're going to do for evaluating functions, I'm going to show you two different types of notation that you're going to see. So the first that you're going to see on your, oh wait, do I even have a copy of it right here? Let me get my notebook and all this stuff. Let me go get it. Make sure I'm using the same one. All right, so on the worksheet that we're going to do, it's going to look like this. For example 1, it's going to say evaluate, and then it's going to have an expression. For example, let's do x divided by 3 plus 2x. And it's going to say use x equals 12. Alright, so when you're asked to evaluate here, these are essentially going to just be order of operation problems, right? The difference in these problems and the order of operation problems that I've given you so far is you've got to plug the number in for x. So whenever you're doing this, a lot of students have had practice with this, can do this very easily. However, I usually have several students as well that they get all mixed up plugging stuff in. All right, so if you get mixed up plugging stuff in, if you write your expression, x divided by 3 plus 2x, what you're doing whenever you plug stuff in is you are taking out the x and putting in a 12, and I usually put parentheses around anything I plug in. Sometimes it doesn't matter, like here, if you left them off, it'd be fine. But over here, whenever we take out this x, if I don't have the parentheses, then it just looks like it's 212, which is not correct, right? So I usually put parentheses around everything that I plug in. So you are only erasing just the x, and you're just replacing that with a 12 in parentheses. All right, so if you need to, actually write it down with the x, or erase the x and put the 12 there. Most of you, eventually, as you get better, you'll be able to do it without having to actually write down that x. So whenever I look at this, Marley, what should I do first? Marley is correct, though. We should divide here. And so we're going to divide here, and that's going to give us 4. Plus, what's the next thing we would do? Peyton, go ahead. What would we do next? We can pull this down and multiply, or if you want, you could go ahead and do it in that same step, since it is the next step that you would do, right? So, what do we get when we do 2 times 12, Peyton? 24. All right, and then, so the last thing we need to do here, Passion, what do we get? 28. Okay? All right, let's do a few more. This time we're going to evaluate um, 6a minus 3 times 2 minus b, and we're going to use a equals 1 and b equals -3. Now I'm going to do it like I did last time. I'm writing this down, and I'm going to erase. You don't have to do it this way, but I'm telling you, students get mixed up on plugging in, and this will fix your problems if you do this. So, I have an A and a B that I have to plug in this problem. So, for my A, I'm going to erase just the A right here, not the 6, just the A. and I'm going to plug in a 1. I'm going to put parentheses around it. Okay? Right here's where students get messed up. It's plugging in this b. Alright? So when you plug in the b, you erase just the b, and you're going to plug in -3. A lot of students get mixed up because you got that minus and that negative there, so they might not write it correctly if you just plug it in. So that's why I kind of like to do the erasing. When you get good, you can do all the erasing in your mind and just plug it in. Some of you might already be good, but probably not all of us, right? So I got to figure out what to do here. Zane, what should we do first? We can, because right here, that double negative right there, it becomes a positive, right? So we can go ahead and put those together, and they're in parentheses, so that's what we need to do first. So I got 6 times 1 minus 3, and then 2 plus 3 is going to give us a 5 here. All right, what would come next, Zane? Good. 6 times 1 is going to give us 6. What would be after? I could bring everything down if I want, but I can, we get kind of sick of writing everything down. Sometimes we like to condense this a little bit. What's the next thing you got to do after your 6 times 1? The 3 times 5. So I'm going to go ahead and do this in the same step. If that messes you up, don't do it. But 3 times 5 is going to give me 15. And then last step, I got to do 6 minus 15. What's that going to give us, Zane? Perfect. -9. Very good. All right, different signs there. I got a positive 6, negative 15. So I got to subtract them, keep the signs bigger. Okay, questions? All right. Let's do one more like this, and then we're going to look at the other type of notation you're going to see. All right, let's do evaluate x, y squared divided by 5. Use x equals 2, y equals -5. Okay, so again, I'm still doing this to be extra sure everybody knows how to plug stuff in. So I've got a 2. So for my x, I'm going to erase my x, and I'm going to put a 2 there in parentheses. And then for my y, it's -5. I'm going to erase the y, just the y, not the exponent that goes with it. And I'm going to put my -5 in parentheses. Now, of what we have here, Laura, what should we do first? What? Sorry, I still couldn't hear you. We do not do the 2 and the -5. There's something else that's got to come before that. We got to do the exponents. PEMDAS. Right here is our exponents. And we haven't seen a lot of them, so it's easy to skip over them. But we got to do those exponents first, which means we got to deal with this part of the function right here first. So, -5 squared, what is it? Is it -25? It's not -10. It's just 25, because whenever we have -5 squared, it's telling us to multiply that by itself twice, right? which means this is negative 5 times, sorry, it's, have I told you I haven't told you guys my theory about this. Here, I need to tell you in a second. It's 5s that mess it up. It makes it go crazy sometimes when I write 5s. I'll tell you about that in a second. But negative 5 times negative 5, negative times negative is going to be a positive 25. So I've got 2 times positive 25 divided by 5. Be careful with this, because you cheaters out there, you're sitting at your house, you're like, I'm sick of this, I'm not doing it anymore, I'm using the calculator. Negative 5 squared is negative 25. This is not right. The calculator is lying to you. Negative 5 squared is not negative 25. If you type this into the calculator, you have to have parentheses around your negative 5 before you square it. Same thing if you do it on Desmos, it's going to work the same way. You have to have those parentheses around it. And guess what most people usually forget? They're parentheses, and they don't know any better, so they believe the lie the calculator is telling them. Right? So be careful. First of all, you're not really allowed to use a calculator yet on any of this anyway, so it shouldn't be an issue. But if you're a cheater and you're at home cheating, I'm trying to help you out here, cheaters. It's not negative 25 if you're using that calculator. All right, so next, what do we have to do? We're going to multiply. 2 times 25 is 50. Divide it by 5. We get 10. See, okay, I'm going to pause it. Alright, so, alright, we're going to do some different notation this time. So we're going to use function notation, and I don't know if Miss Ball did this any in 8th grade. She might have, just because she used to be a high school teacher and she knows you're going to see it, and she might have thrown it in, but I don't think it's something you have to do in 8th grade. So, have you ever seen something that looks like this? That F parentheses X, F of X. Maybe a little bit, maybe just a little. Yeah, so, Gabby. Alright, so, this right here, we read it as the function of X. For right now, I'm just teaching the notation. I am going to teach you a lot more about what it means to be a function, but just not right now. I just want to introduce it right now because you're going to see this a lot, so I want you to be familiar with what it means whenever you see this, okay? So this means the function of X. So you're going to be given a function of X. What it's telling you here is this is my formula, right? So you'll see something like this, and it'll say find f of negative 3. Okay, so I promise this is really simple. It's just new notation that you hadn't really seen it written like this before. When it says find f of 3, what it really means right here is plug in x equals negative 3. So plug in negative 3 for x. That's what it means. So, what this is saying is it's saying, here's my function, here's my formula, here is what you're going to use, so here is 4x minus 2. Plug in negative 3. So when you see this written this way, it's just really another way of telling you to do what we were doing on the first 3 problems, right? So if you've got 4x minus 2, you can erase that x. You can plug in your negative 3 in parentheses. and then you're just simplifying here. So, whenever we're doing this one, Katie, what should we do first? Multiply. So 4 times negative 3, what's that going to give us, Katie? Good. And then what do we do last? Yep. We're going to subtract. What will we get? Not negative 10. Negative 14. You got the same sign there. So I usually just think, you know, like here, you can do the plus the negative. I usually just think like, here's my negative 12. Here's my negative 2. That negative goes, the sign in front goes with it, right? So you got negative and negative, you got the same sign. So you're going to add them together. So you get negative 14. Or you can think, you owe me $12, you borrow $2 more, you owe me 14 altogether. Yes. Yes. They're the same as the other ones we just did. So it's new notation, but it's the same thing you've already been doing. So after we do a few, I don't think they'll be too confusing for you. So let's do another one. We've got, this time I'm going to use a G of x. It doesn't matter what letter's there. It might be a G of x, f of x. They're generally not going to do x of x. But this is just saying, here's my formula, right? All it's saying is, here's my formula, and I'm calling this formula G. Whereas up here, I'm calling this formula F. So, G of x equals x squared minus 6x plus 2. And I'm going to say find f of negative 4. It's important to know G parentheses x, that does not mean G times x. Right? G is not a variable. It's just saying, here's my formula, and I'm calling this formula G. Sometimes we might have several formulas that we need to talk about. So it helps to have this notation, so I can call this one F, and this one G, and this one P, or something like that. All G of x is saying is, here's my formula. So the formula you're using is just this part right here. And then when it says find f of negative 4, I've got this negative 4 in parentheses. That's just telling me to plug in negative 4 for my x. So we're going to have, I'm going to write it like I've been doing, and erase. You might be sick of it. Like, just do it in your head. But I like to be really clear. So we erase the x. We put the negative 4 here. We're going to erase the other x, because there's 2 of them here, and put the negative 4 here. So you can see it's the same thing as what we were doing before. It's just different notation giving you the formula. These will only have one variable in them, so that's good. Some of the other ones might have 2 or 3 variables. Okay, so let's see. Somebody hadn't called on today. Let's see, Ayla, what would I do first? Okay, good. And what am I going to get when I do negative 4 squared? Good. And I like that Ayla said it's positive 16, right? Because this means negative 4 times negative 4. Negative times negative is going to be a positive. So positive 16 minus 6 times negative 4 plus 2. What would I do next, Ayla? Very good. What's that going to give me? Good. And since it's positive, negative times negative is positive, I'm going to have a plus 24 there. And what comes after that, Ayla? Okay, we can do the 24 plus. Technically, we're supposed to go to left to right. Since this is all addition, it doesn't matter. It would matter if we had subtraction there. So let's do the 16 and 24 first, although it is okay to do 16 and plus 2 here because addition, you can mix it up. But if that was a minus 2, then we couldn't do that. So 16 and 24 gives us 40 plus 2 is 42. Yes? Okay, so the way I thought of it is I kind of did like this. I did it in my head. So, like I did keep, change right here and made that negative 6 times negative 4 right there, which gives you a positive 24. Another way you could write this is you could think of it just like doing this part right here. 6 times negative 4 is negative 24, but you also have this minus out here. So if you did it that way, you'd have to have minus negative 24, which eventually becomes a plus there. Okay, other questions? Yes? Where are you having trouble?
I think, like, when you get it all together, no, that's easy. I'm trying to figure out, like, what we're trying to do.
Where you're supposed to put everything. Let's do one more, okay? So, and I'll let you help me with this one, Passion. So, example 6. Let's say that K of B equals B. Oh, let's do this. Let's do 3B squared minus 2B plus 4. And we're going to find K of negative 1. I'm mostly using negatives here just because they're harder and we need to practice them. So you got different variables here, but what this is telling you right here, it's saying K of B equals this. Notice B is the variable they use. It's just saying here's the formula, right? So don't worry about that K of B. It doesn't mean K times B. It's just saying here is my formula and I'm calling it K. All right. So when it says K of negative 1, that's telling us plug in negative 1. Okay? So for whichever variable you've got in the formula, which in this case is B. Right? So we're plugging in negative 1 here for this B and for this B. Alright? So that will look like this. I'm going to do it like I did before. So 3B squared minus 2B plus 4. So we're erasing the B, just the B, nothing else. And we're putting the negative 1 there. And then over here, we're erasing the B. And we put the negative 1 here. So don't use this K of B stuff right here. We don't use it to evaluate anything. It's just telling us, here's the formula, and I'm calling it K. Right? So we don't use that part. And then whatever number we're finding K of, that's just telling us to plug in that number for our variable. Does that make sense? Okay. So when we look at this one, Passion, what would we have to do first there?
The 3 negative 2. I mean, the 3, the 1, and the 2.
The power right here, right? We're going to leave the 3 alone right now. Negative 1 to the second is what we're going to do. What is negative 1 squared? It's not negative 2. It doesn't mean to multiply. Negative 1 squared means negative 1 times negative 1. So exponents mean we're multiplying that number by itself. So we get 1 there. So it's going to be 3. And instead of this stuff right here that we just did, I've got 1 minus 2 times negative 1 plus 4. What would I do next? Good. That's going to just give us 3. I'm going to go ahead and do the next step because what's the next thing you would do after that? You're going to multiply this negative 2 and negative 1. What's that going to give you? So I like to do this. I like to think that 2, I'm going to just take the sign in front of it, right? So this -2 times -1. Negative times negative is positive, which means I'm going to put a plus instead of the minus there. Yeah. So the way I like to do it is to think of these 2 numbers right here being multiplied together, and then you're just using whatever sign you get, positive or negative there. It can be done the other way, but you end up with double negatives, and that gets confusing to me. So, and we're going to bring down this +4. All right, so what would we do next? Good, so we got 5 plus 4, and that is 9. Okay, does that help some?
Yeah.
Okay. All right, so I've got 2 things that we're going to do. So you will need your computer. We have not done delta math in this class yet, have we? You guys used it last year, though? Oh, it's not terrible. I like delta math a lot better than IXL. I like delta math because it tells you if you got it right or not immediately. Whereas if I give you a worksheet, you might do 15 of them wrong. I still like worksheets too, but you might do 15 wrong and think you're doing it right, but delta math or IXL is going to tell you, hold up, you've not got this, right?
No, it's like what she made us do, like, what was it? Angles and stuff like that. Yeah, like all
Some things can be hateful, yeah.
And you had to get, it was like 50 problems.
Today is just evaluating functions and typing in at the answer 7, so it shouldn't be, hopefully, too frustrating for you. So, your classwork today is going to be to do delta math, and I've got it set, I think, where it's going to be 8 questions or maybe 10. So, you guys should have delta math accounts from last year. So, I think you just need to go and log in, which you can log in with Google, and you're going to have to add a new teacher code. I put this on Canvas, but I'll put it here on the board too, so you don't forget to Canvas. Teacher code is 459911. There. So go to Delta Math. You're going to use this teacher code and tell it that you want to be in my foundations class, and it should take you there. And then you should have an assignment that says 1.6 evaluating expression or evaluating functions. Hopefully, all of that's going to work as I have told you there.